In 2016, I remember being here on the Microsoft campus over in building 16, which is where the SQL team used to be. And was in some meetings with some of our leaders and executives. And in this room, they announced to our team that SQL Server, we were going to launch an adventure to build SQL Server on Linux. Now, this is my 30th year at Microsoft, and I've heard that idea proposed about 5 other times throughout my career, but I didn't really believe it until a gentleman named Slava Oaks used to be our technology leader for SQL Server. He works at a different organization now. He showed a demo. He showed SQL Server running on Linux. We're like, what? We just couldn't believe it. So then the next thing that Slava showed is that, well, because we're running on Linux, we can run in containers. And my first question was, what's a container? So I started on that journey in 2016, like everybody else, and eventually, for SQL Server 2017, in that year, we launched a version of SQL Server that runs on Linux and with containers. And when we first did this, I'm not sure we quite knew the path we were going down. So I'm Bob Ward from Microsoft. I'm a principal architect on the Azure data team. I've just talked to a few folks here up front. I'm actually from Texas, like 40 degrees hotter there. But I do work for the company for 30 years, based in Texas. I did remote before it was a thing, coming up here several different times of the year, but also traveling around the world, quite frankly, talking to customers. I used to do some stuff like coding and those kind of type things. Now they just kind of pay me to speak about SQL Server, but also do architecture work for our product. And everything actual SQL, edge to cloud, whether it's SQL running in Azure SQL, VMs, containers, Linux, or SQL Server. So here's what I'd like to do today. I would like to talk about containers first, about what are they. So we just kind of ground set ourselves on what is a SQL Server container and how might you could actually use it. But what about this DevOps thing? So we're going to talk about other technologies that we have built for developers to help you do things like database projects, DevOps types works. And then we'll conclude by talking about how do we integrate this in an environment like GitHub? Like how do we put all this together in a way that you can take advantage of SQL containers for databases, develop free, and then actually even publish things to the cloud if you need to do that. So one thing I like to do when I do presentations, and I love coming to VS Live, I think it's about like a 4th VS Live I've been coming to, is I want to make sure I have all my content and everything I do. So do you see this URL at the top up here? Feel free to take a photo right now. The final slide that I'm doing today, I'll leave up, has those same links again. The first one is a link to all my presentations. So right now, if you go up there, there's not a folder yet for VS Live, this particular event, but I'll do that today. I'll put a folder called VS Live 2023 Microsoft HQ. And you can go there and you'll be able to have this deck in its full entirety. But what is already there is a site called Bob SQL Demos. That's a GitHub repo I've built, and all the demos I'm showing you are there available for you to try. You can just go through step by step on GitHub and do them yourselves. Of course, one of the cool things about this is because SQL Server itself has something called Developer Edition, it's all free. So you can actually go through all these demos without spending a single dime, because even the GitHub demos use a concept called GitHub Runners, which can be free to use as well at a small scale. So with that in mind, let's start going to the content, but let's talk the logistics about questions. We got a lot of time, we have 75 minutes. So what I'll do is I'll go through a section of material and I'll stop and say, hey, what kind of questions you have? And we'll have time for all of them. I'll stay here afterwards if I need to as well. I'm also going to be later today at your Mixer event. We have some keynote rehearsals to do because, kind of related to what I'm talking about, tomorrow afternoon, my Vice President Assad Khan and some of my other colleagues will be here to do a keynote to talk about Azure SQL Database as developers. But part of that story is how we're going to help you use containers to do free development for Azure SQL Database. So lots of opportunity to talk to. And my team is also here tomorrow and Thursday doing other presentations about T-SQL programming and about database development in general. So I don't know if this is your environment or not, but I've seen this before many, many times that a company will have a single SQL or maybe multiple SQL instances running somewhere, could be in the cloud even, like in a virtual machine, and they share it with developers. So in this scenario, you could have these developers all having different databases on a SQL Server instance and sharing it. And it seems okay to do this. You're isolated. Everybody has their own database, which is all great. But who manages the virtual machine or the instance? So for example, what if you got to take the instance offline? What if some developer has rights to say, well, I'm going to take this down because whatever I'm doing, I got to restart SQL. Everybody's down. You're all affected. So it may seem like you have this isolated model with databases, but because it's a single SQL Server instance, it's not. Now, there's a couple of techniques you could do. You could create multiple SQL instances, one per developer. That's a possibility. But you might lose consistency for developers working on, say, the same application. You could use the cloud. The cloud is a way to do that. We have something called Azure SQL Database where that's an isolated model. But of course, you're paying them for an Azure subscription. So a lot of people, though, could use developer edition of SQL Server in this model, and it's free to actually develop on and do testing. But is there a way to do this where it's not so shared, it's more isolated, it feels like developers can develop on their own, but still be consistent? And containers are a way to do this, and it's multi-platform. So for example, I could have maybe a consistent database schema of all tables and objects and procedures and everything that I share across the development team to use. Each one of them can work on their own laptop if they need to, or even something called GitHub. You've seen GitHub in the cloud before as well. It could be like a virtual machine in GitHub. And notice here, though, if it was using their laptops, it could be Mac, it could be Linux, Windows, doesn't matter, because you'll find out that a SQL Server container is a consistent image of SQL Server, regardless of where it's running, because of the power of container technologies. So in this particular case, everybody uses their own container, but as an organization, we can build something called a custom image. We'll talk about how to do that for consistency across these developers, and it works across all the OS platforms. And then we'll show you, using this in combination with our DevOps technologies, you could be all working in the same project doing this model. When I started talking about SQL Server containers back all the way in 2017 and 18, customers would come to me and say, hey, is anybody using containers in production? And they are today, actually. We have customers using a container actually as a production version of a SQL Server. But the first thing I tell them is go do this. Go look at your development environment and see whether you should go deploy something like this to make your developers more effective. So you're not all burdened by a shared SQL Server instance. So with that context in mind, let's talk about what is this thing? What is an actual container? So let's stop and ask a question to the audience. How many of you actually use containers at all today? Anybody know what a container is? You use containers? I got a kind of some hands a little bit here and there. So you're familiar with the fact that a container is based on an image. And so for SQL Server containers, it is an instance of a SQL Server container image running in an isolated fashion. So we'll talk a little bit about just containers in general in a second, so you get a feel for why is it different from running like a process in a virtual machine? Like, is it different, right? It is, but it actually complements virtual machines, doesn't replace them necessarily. So think of an instance of a SQL Server image running in an isolated fashion as a process. So what's a SQL Server image? Well, it's a binary image. There's a protocol for how to go build images. There's tools to do container images to build them. And SQL Server container images are a pre-installed version of SQL Server on Linux. How many of you have been through the installation process of SQL Server on Windows today? Anybody tried that? You go through the steps, the GUIs, the whole thing, right? So when you pull and run a container for SQL Server, a SQL Server container image, it's all pre-installed. Everything's there. In fact, so it's one of the quickest ways to get up and running with a SQL Server to deploy it. Because by running a container, within like 30 seconds, you're just running SQL Server all of a sudden. So we've built these images in a way that it can just start running as soon as you run the container. One thing that I haven't pointed on the slide that you should know, because people have asked me this, if it's this binary image, how do I trust it? So we have something called the Microsoft Container Image Registry, which is where our container images go. And we run virus scans. We run several things on that registry where these images are to ensure that they're secure for you and safe. But we publish them all out there, and we tell you globally across the internet, how would you get access to these things? So what are the images for? Well, we started this process with SQL 17. So there are images in our registry, container images, for SQL 17, 19, and the newest version we just released, 2022, and cumulative updates to go with those based on Red Hat Linux and Ubuntu. So all those versions are out there, and anytime we do an update for a SQL Server, we call it a cumulative update, like a patch that we're doing, we post a new version of an image that lines up with that. So, for example, in your organization, you all agree that we're going to be on SQL 19, some cumulative update, because that's a standard in our company. CU, we call them CU6 or something. Well, it's pretty cool because you can just pull down a specific container image that has that CU in it, and you're already ready to go. So you never patch anything. So for SQL Server patching, we just produce a new image for you to use versus you having to go run some hotfix installation to actually patch the image. So that's what a SQL Server image is. And what is in it? Well, first of all, there's binary files in there to support the actual operating system, like Ubuntu or Red Hat Linux. And then there's the SQL Server software itself. And what we include today is what we call the core SQL engine and tools, like command line tools. So if you think about anything you need to do with SQL Server that's the core engine, you think about security, performance, availability, query processing, all the stuff we normally have in our database product, it's all contained in this actual image itself for a container. And then it's just SQL Server. So when I first presented this, I started talking about all the diagrams for the container and how it works with Linux systems and so forth. Somebody said, well, like, how's it different than SQL Server 2019 that's out there today? I'm like, it's the same. It's SQL Server on Linux. So if you installed SQL Server on Linux, I'm just giving you an easier way to run it. And as a developer, a very isolated way to run this in your environment. Okay, so I need to make sure before I move forward, though, that you understand about SQL Server 2022, because when you're looking to see, am I going to start using these containers, again, a free developer edition for you to use, what's in the thing? So in SQL Server 2022, we have cloud-connected features. You could even go out there and do development and testing developer edition for free and test connectivity to the cloud for things like managed disaster recovery or something like that. Then there's a whole set of range of query processing capabilities called built-in query intelligence. What do I mean by built-in query intelligence? It sounds like a fancy AI term. Okay, here's what it is. Our query processor is the thing that handles your queries. You send select statements, insert, you send all these SQL statements to our engine. We have built technology in our query processor to recognize query patterns that come in and on the fly adjust and make them faster. That's what it comes down to. So we've looked at common problems that developers and SQL professionals have run into when they build queries with applications, and we try to figure out how can we adapt to your workload versus you having to go tune every single thing you send to the server. So that's called built-in query intelligence, and we've started that process with SQL 17 and 19, and 2022 has even more functionality for it. Then there's core security capabilities, availability capabilities, and performance capabilities like scalability. Here's one. Is anybody interested in doing blockchain technology? Not Bitcoin mining, blockchain technology. Does anybody know what blockchain is? Blockchain is all about tamper evidence of data, like trusting data. And it's usually a distributed system. We have now built a blockchain in the engine. You can go create tables in a SQL Server engine in a container, and you can achieve and have blockchain functionality inside the database engine itself. We call it Ledger. And that came with SQL 2022. And here's the cool part. It's in Developer Edition for you to test for free. But has anybody ever heard of SQL Express? We built that thing a long time ago, didn't we? That's a free version to use in production. Now, it's got limits on its sizing and so forth, but Ledger's even in Express. So even allowing people to run production systems with a blockchain technology. I had a customer that didn't have a large database size and wanted to run this blockchain across many different stores in their environment. And they're doing it today with a free version of SQL Express running Ledger technologies in their database. Now, does any of you consider today as a developer looking at things like Parquet files, Delta tables? You've heard of data lakes, maybe you've been working with before. There's a buzzword out there, right? Data lakes. Well, SQL participates in that technology, and here's how. You're used to using tables inside a SQL Server engine itself, could be a container. But you may be in an organization where your data is sitting out in a lake somewhere like a Parquet file. So how do you access that typically? Has anybody ever queried a Parquet file before? Anybody written code to query Parquet? What might be a technology you would use to do that with? Anybody use Spark? So Spark is a technology, typically Python Spark books to go read things like Parquet. But do you guys want to go write that and write SQL? No. So in the SQL Server engine, in your container that you're developing for free, the SQL language can go read Parquet just like a table. We call it data virtualization. Even better, you can take SQL as a technology and export your SQL data as Parquet somewhere else in a different data lake. It's kind of like a way of doing archiving of cold data. So all that comes in the engine with SQL 2022, and that's supported even back to this Express edition I talked about. And of course, as a developer, remember, as a developer for free, you're developing SQL Server. A container, when you first pull it down, by default is a free dev edition of SQL Server. You then go, and we'll talk about how we do this in a second. If you want to go deploy this container in production, you would then go specify an argument to the way you run it to say, oh, I've got a paid edition now of SQL Server. But remember, for free, when using containers out of the gate, it's a free development experience. And then finally, we believe in the SQL language is still powerful for developers. We don't want you to put all the logic in your app all the time. Maybe you should use the SQL language for it, like JSON. So we support JSON types. We have all sorts of different T-SQL functionality. Anybody ever work with time series data? So we have T-SQL functions to help you process data in buckets and intervals, just like a time series type information you'd have in your database. All of what you see right there in SQL 2022, which just came out last November, all of it's part of that container experience we first talked about. That's that pre-installed version of SQL Server. One last thing about this as a developer you should know, and it's not on the screen here, something called DB Compat. Does anybody know what database compatibility level is for SQL Server? You do? What is database? So you didn't even get questions, did you? What is DB Compat? What does that mean to you? Yeah, backwards compatibility for like language statements and syntax. But this is the other thing that's interesting about it. It helps protect you from things like query plan changes. So you could actually go run a SQL 2022 container, create a database in there, make the compat level back to maybe a version you were using like SQL 17 or something, and all of a sudden your app doesn't break, right? Because the syntax is going to be recognized back at that level. Your query plans aren't going to change. And even more importantly, these newer compat levels that would come with like a new version, every time we have a new version, we raise the compat level, it lights up new stuff, like that intelligent query processing stuff I talked about. So you can actually, as a developer, start testing with an older compat level, then change to the new compat level, and then this is something that it's not even up there. There's something called the query store built into the engine. So you can actually turn on the query store and track performance of your queries across those compat level changes and compare and contrast. Was it faster? Was it slower? What I needed to make sure I'm running on the latest and greatest stuff. So keep all of this in mind as you think about what containers are as a technology. So I built this way back when we first started talking about containers because I was in a session one time with an expert I really admire in the industry. I was listening to their presentation, and they called a container a lightweight virtual machine. And I almost fell out of my chair. Like, why would you say that? Because they presented a slide that showed a container, which again, for SQL, is an instance running in an isolated fashion, so it's a process. They presented it as some sort of abstraction layer to get to the operating system. Look at my diagram. Each container running SQL Server here has the necessary files in it to run the engine, but notice it talks directly to the host operating system. Do not think that a container can't be fast. That is bogus. You can go develop on a container on your laptop, and provided you're going to go test in production with a similar type machine, you got to keep in mind cores and memory and speed and so forth, right? You're going to get the same performance. Because containers are running directly, all the memory, all the threading, all the things we do directly to the operating system, a container has full access to. But here's the trick. Containers, when they're run by what's called a container runtime, use operating system principles to isolate the processes. So they don't know that other processes are running. So if you're looking inside a container, you will only see what's running in the container. But look at this, the diagram. This could be a virtual machine where you're running multiple containers. In fact, for SQL Server on Windows, we have a concept called multiple instances. Maybe you've seen that before. We don't have it on Linux, but we have this. So if somebody asks me on Linux how to run multiple instances of SQL on the same virtual machine, consolidation, I'll say go do that. Go run multiple containers because they're isolated. They don't know each other is actually running. Now they got to share resources. You got to figure that part out. But SQL Server has configuration commands to do that. Give this much memory to this one, these many CPUs to this one. We have all the control that needs to happen. As a developer, you typically are going to run one container in your environment. But if you have to go start an environment where you're going to share a virtual machine, like I first showed you in that diagram, you could use multiple containers for each developer, and each of you could have your own database running in there. A huge concept for containers is something called persisted storage. Inside that dashed line you see for that container is a file system that's mapped to storage. But if you remove the container, everything in there is lost. That's a problem for a database. You don't want to go lose your data, right? So container technology allows for a concept called persistent storage, which is like a separate file system outside your container. And typically, for a SQL Server environment, you'll put your databases there. That way, if you remove the container, your databases stick around. And also, it provides a very nice way to update SQL Server. So if you, as a developer, had a container running in your laptop with SQL, running a certain cumulative update, and you wanted to go to the newest one, you don't patch it, you stop the current one, you then take the new one and start it up with the new updates and point it to your databases, and it just works. So switching now is a way to do updates for a program like SQL Server because of that technology. So consider these points as you're thinking about it. Make sure you understand this behind the scenes. All platforms supported, Mac, Windows, and Linux. You're probably wondering on Windows, how do we do this? You ever heard of the Windows subsystem for Linux? So we have that. So SQL Server Containers can run in that environment. So it's kind of virtualized, right? But it's still running Linux. So it's portable. That's the beauty of it, right? Anywhere I can run a container, I can run a SQL Server container. And it's lightweight. Notice, in this environment, somebody may have decided to run multiple virtual machines for this, but I only ran one to run 3 SQL servers. So it can be more lighter weight from a perspective of consolidation, how you run the programs. And then it's consistent. That is one of the biggest selling points here. If you want all your developers to run the same test and develop in the same version of SQL, it's very easy to do that with containers. But we'll also talk about a way where you can customize the SQL container image and add your own things to your own image to make sure you're working off the same set of scripts or schema or tables or object, whatever you need to do. And again, I talked about this efficient concept, faster deployment because it's pre-installed. We'll see in a demo here in a second how fast it is to run one of these things. So this is what it looks like. If you use, for example, Docker, which is one very common container runtime system out there you've probably all heard of, they have a client tool called docker.exe. And a typical, in the Linux environment world, would be say, hey, go do a Docker run, and these represent arguments to the Docker run command. Let's talk about what they mean, because it's important to understand when you're running one of these things, what does it do? First of all, if you run a container, and at the bottom, that's the image we're using, and it doesn't exist locally on your laptop, we will pull the image first. So it's just like a download. So if it doesn't exist locally, like a cache, we'll pull it from the Microsoft registry, we'll put it down your laptop. That's why the first time you do one of these things, it can take a little longer because it's pulling it down. So the first argument, or the first argument is environment variables. So for SQL Server, because it's pre-installed, you need to accept our license agreement. That's one of the arguments. And notice here, this is something called the system administrator password. Containers do support Active Directory authentication, but out of the gate, to get it deployed, you need to give us the administrator password that you're going to use for the system. Next is a port mapping. Has anybody ever tried on your laptop to run 2 SQL servers just by default at the same time? I mean, you ever running a SQL server, try to spin up another one real quick? It doesn't work because we'll have a port conflict, because SQL by default listens on port 1433 for TCP. So you 2 can't listen on the same port at the same time. So typically use this environment variable to map a port to 1433. So for this container, remember I can have multiple of these? I'm going to connect on port 1401 for this container, which is going to map into the image itself to the default SQL port. Next is my persisted volume. So here's like a mount point. This directory, var optms SQL in Linux, is a file system mount point inside the container image. And what I'm telling Docker is, anytime anybody puts a file in there, map it to a separate persisted storage volume, which could be a drive on your laptop, a separate drive, or even a network drive. So again, that's how you're going to make sure your databases stick around, even when you remove your container. The next one's important. The host name parameter to Docker feeds into SQL as AT@AT server name. So if you ever go look at your server name for your SQL instance, use the host name parameter to dictate what that name's going to look like. And the name here is for Docker, not for SQL. So if you're going to go manipulate this Docker container instance, with like stop it, start it, remove it, it's easier to have a friendly name with this. Otherwise, it creates some sort of, it's actually funny the names it creates. It creates these really weird names of different famous people or something. The next one is something that says run the process in the background. Have you ever tried to go to your SQL Server environment and run SQL Server from the command line? Type in SQL Server. I use this as a trick, by the way. I used to be in support. So if you can't start your SQL Server as a service, I'll ask you to go in from the command line and start it because SQL can run from the command line. And when we do that from the command line, it dumps out the error log on your console window. Like all the screen stuff starts dumping out. So run this in the background. Otherwise, when you run it, you'll start dumping out the command line because one of the ways we run this container for you is we just run SQL from the command line in the container instance itself. So -D says run it in the background to not see it. But I've used this by removing that flag if somebody can't run their container. Like, hey, go take off the -D, and it might show an error of why it can't start up. So it's a debug, a tool to use. And then finally, most importantly, there's the image. That's the syntax for where is that image located. That mcr.microsoft.com, that's the Microsoft Container Registry. So that's where we're going to put all of our container images. And we document what's the path to find SQL 19, 17. Latest, by the way, means just find the latest update of SQL 2022 out there, or it could be you specify a specific update you want. Okay, one last thing before we show a demo is I told you you could customize an image. Docker as a runtime, as a client, has tools to do that. Docker build or Docker compose. What you're going to have to do to use this technology is build a text file called a Docker file. And there's a protocol and a syntax for it. Here's some examples. So I could, in my Docker file, put the word from, and notice there's that SQL image. Notice the next command says copy a file which is locally in my folder where I'm running the Docker build command from. Copy it into that directory, which is where the SQL databases go in the image, and then start SQL Server. So if I say Docker build with that, do you know what it builds? A new container image called whatever you want, my image, that includes SQL Server. And when it starts, it does that. It copies this backup file, and it runs this command. Oh, sorry, the backup file's in the image. So the command is to start it up. So you're effectively doing the same thing we do to run a SQL Server container, but you're overriding it by adding your own thing to it. Why would you want to do that? Well, it could be a backup from your company that you want to use for test purposes, but we want a consistent backup for your developers. So once you start this, you would then just do a restore backup command once you started the container in SQL, and then you're ready to go. Another method is I want to run scripts. So I call this the venue method because a former colleague of mine, venue, showed me how to do this many years ago. And the concept is this. I have several different scripts I want to run to start at the container. For example, I'd like to create a new database with a bunch of tables and stored procedures and objects through a SQL script. So the way we do this is this. The Docker file is going to say, I want you guys to copy these files, run this command to set the right permissions, and then notice the command to start the container is running what's called the bash shell inside Linux to run that shell script. Well, what's inside that shell script? That shell script says, hey, first go run this shell script, and ampersand says run it in the background. So this shell script starts off, then SQL Server will start off. So I'm doing both of these. But wait a minute though, if the server starts, how do I run my SQL commands? How do I time this? Well, notice this trick. I'll sleep. So I'll wait about 15 seconds, and then as SQL is starting up, this script will then after 15 seconds run SQL command, which is inside your container. Remember I said the tools are in there? It'll run SQL command with your SQL script. Well, what's my SQL script? What's my create database statement? So when I build one of these custom images and I start it up, this runs first. This waits 15 seconds for SQL start, then runs this. This actually takes that SQL script. And now when the container is started, I have SQL installed and my database installed. And I could give it to all my developers and say, everybody use this to go build on and write your app on. It's a consistent way to have a development environment for containers. Okay, enough slideware. Show me the money. Okay, so what I'm going to do first, I'm going to show you a little bit what these GitHub repo looks like. So in my GitHub repo, I have README files that talk about what to do. And I don't memorize demos. So I'm like, what did I say? What are the steps to run here? So I've got some scripts for you. Let me go first over to PowerShell and show this for you. This is the run container command. Now I'm using PowerShell, but notice I've got an SH file. So if you're a Linux user, you can just run this as in a bash shell in Linux. So Docker comes as a Windows client as well. And if you go look at this, I'm going to use this sophisticated editing tool called Notepad. This is very similar to what you saw me do in the slide, right? These are the same type of arguments I showed you before. So let me go kick this off and see what happens. So remember, we're going to run this in the background, so we're not going to see anything show up. It's like, oh, Bob, what happened? I just started SQL Server. That's it. I actually set up SQL, deployed it, and ran it all in one step. And you're like, I don't believe you. So first of all, what we're going to do is we're going to see, okay, well, why don't you just try to connect to it? Now, I'm using this password right here. So maybe you've seen this tool called Management Studio, like half the world uses. And notice here I'm using localhost 1401. That's the port mapping I talked about. I'll put in my password, say remember password, go. There it is. And notice it looks just like SQL Server on Windows. I mean, this looks very similar to what you're used to seeing. So you're like, well, I don't believe you. I'm like, fine, I'll just go create a database then. So let me come up here and say, how about this? Rangers in first place. Yeah, that's a good database name, man. Yeah, sorry, Astros fans, stick it. So I'm going to go here, and I'm good to go. But you're a developer, and you're like, I need to do tracing. No problem. We have something called Xevent Profiler. Kick that off. And also with Xevent Profiler, I can do anything I want. I can start if I just actually go here and refresh the Object Explorer, you'll see queries start showing up. So I'm trying to prove to you this is SQL Server. This is what you're used to using. So consider what I just did as a developer. Like in a matter of like minutes, I installed SQL, I started running it, started creating databases. I'm up and running very, very quickly on my laptop, distributed across all my developers in the organization. And that image could have been that custom image I wanted, right? That I built with my database already in it. So I could have given that developer, I could have Docker run that image. It could have been stored on a network server somewhere in my environment. It could be stored in the cloud. We have something called, in Azure, we have a container registry in Azure. You can create your own registries with privacy and security built in. You have all those options to you. Let's take a look and poke around and see what this container looks like a little bit. What can I look at some? So number one, just to get familiar with Docker a little bit, if you type in Docker PS, that shows you what Docker containers are running on your machine. And you can see this is the one that I actually started with SQL Server there as well. I could do something even more interesting. What I'd like to do is, I told you you can actually run something in a container. Like I'd like to go run and look at the error log in my container. So this command here, exec, whoops. Back in, yeah, here we go. Yeah, that's a special notepad. Notepad. Wait till you meet my colleague Davide Mari. He'll probably laugh at that. So look at that command there. Like, what the heck is that doing? So Docker has a way for you to run an execution of a program in the context of a container. And the program I'm going to run is bash, the shell inside this container. And IT says run it interactively. So it's a way to interactively run and get a terminal effectively inside the running container of SQL. So let's go see what that looks like and see what happens. That doesn't look like PowerShell. That's because I'm running in Linux now. So remember those directories we talked about? So in SQL Server, just like you might have seen in program files, Microsoft SQL Server and Windows, here var opt ms SQL is the standard directory where we keep everything. And you can see here there's a data and a log directory. So if I go in the log directory and I say cat error log, there you go. There's your SQL Server error log. And the data directory has, if you go back over here, the system databases. Oh, and it has the database I built as well. So now I'm traversing inside the actual container. If I want to go run, and I've got SQL command in there available for me to run if I run queries inside the container. Now, Management Studio is connecting outside the container into the TCP port. Running SQL command is like running inside this environment yourself. Okay, let's exit out of that. Now, the other thing I wanted to show you, though, was Docker Desktop for Windows. This is a new interface that the Docker team has built. It's very powerful. I love this interface. Here's the images I can see in my environment. Now, if you click here, this is what I love, too. The Docker team is showing the Docker file that we built at Microsoft. So our container image has got, remember those syntaxes I showed you for your own Docker file? Well, you can see how we actually built our Docker file for some examples. And then if you go to containers, you can see here, this is the one I'm running. If you click here, look at that. I can go right in and look at logs, or I can go to a terminal session directly in there. So I love some of this functionality inside the actual Docker desktop interface itself versus having to use all the command line interfaces from the Docker client. It's pretty cool. One last thing I want to show you. So we talked about this venue method. Let's see, yeah. So there's a concept called Docker Compose. Let's say you have some sophisticated environment, not sophisticated, fairly regular environment in your laptop where you want to run a container of your app and run a SQL Server container, but orchestrate it together as one deployment. Docker Compose allows that. So Docker Compose is a YAML file that has a syntax to it. And in this particular YAML file, what it says is, hey, for the DB1 container, go to the .bwsql directory where I am and go take the container and run it from there. And I could have another one called DB2 or app1 or something where I could start up and run my application. So it's a way to compose multiple containers in a very orchestrated way. But in this particular case, I'm only going to run one, but I'm doing that same method I talked about for these scripts. So if I go over here, sorry, go here. If I go under BW-SQL, what's in there? Well, notice those scripts that I have. Here is the actual Docker file. So Docker Compose says, oh, there's a Docker file there. Go do that. So here's what it's going to do. This is crazy. Compose will say, I'm going to go build a custom image first, if it doesn't exist. So it's going to go use this Docker file to build one of those custom images with my file, and then it's going to run that container. So let's see what it looks like. And it's using the same files to create the database that I showed you, right? So at the end of this, I should have a running container. So this is what it looks like, and here's how you do it. You say Docker Compose up, and off we're running. Now you're seeing here on the command line the process that it's going through. And when it runs this container, it does not run it in the background. I could have told it to, but you'll see in a second, you probably say, oh, you see some stuff that's going on here from the actual error log file itself from SQL Server. So what it's doing is, it's starting up that container for SQL, it's sleeping for 15 seconds, and then it's going to run the SQL script to go actually create the database files themselves. So when this is all done and it's finished, I should be able to go into Management Studio and see it. So notice here, I put these comments in my SQL script. Those are comments from the actual T-SQL script that's running. And it's actually going to populate some data. You can see it's putting some rows in there. So how do I run this thing? Remember, we have a container R running with port 1401, right? It's like, uh-oh, well, what's that going to look like? So if I go to my containers now, notice here I've got a new one, and it's port 1402. Let me zoom in so you can see this. There's BW-SQL, which is the container I talked at. I told it to use port 1402. So what happens over in Management Studio? I should be able to here and say, hey, let's go over here and connect not to 1401, but 1402. And I'm like, okay, that's great. What password did you use? Well, it's in here. So if you remember in the actual Docker YAML file, let's go run another PowerShell here. SQL demos, DevOps, SQL containers. And if we go look at the YAML file, whoops, we'll see it. Ah, it's the same thing. That's the password I specified. So I'll go in here, copy that, start it here, hit it, go. Boom, I'm connected. And here's the database I have called, that I told you that's populated with tables and with data. So again, now in a matter of minutes, I deploy to my laptop a customized image of my SQL Server and my database for it as a developer. And now I can go start running my app against this. And I've got a consistent way of doing it across my company, my project team, whatever thing I want to go do. Questions? Let's stop and see which I've thrown a lot at you just to start with SQL containers. Let's see what you think about it. Go ahead. The question is, does it support Windows authentication? It does with Active Directory. Set up Active Directory for a container and do with a domain controller, for example, and do a Windows auth. Absolutely can. Yeah, so you don't set up the domain controller in the container. It'd be something outside your actual container to do. But there's a process to set up that container when I deploy it to say, hey, use Active Directory, and then you can create AD logins with it if you want to. Same thing. SQL and Linux supports. So what we're doing, SQL and Linux supports Active Directory authentication already. So we're just allowing you still to do it with a container. but you still have to supply an SA password to start with. Now, at that point, by the way, you can disable SA if you don't want to use it anymore and just use your Windows authentication logins. But you got to always start with an SA password to begin with. We need that to kind of bootstrap the product. We don't support yet Active Directory Authentication, Azure Active Directory Authentication, or what is it called, Entra? We don't support Entra yet, but we will. Other questions? The question is that, are there any issues trying to use linked servers? And no, you can use linked servers, but only SQL Server linked servers today, not third-party linked servers. And in order to do linked servers, though, you got to be a little bit tricky because you got to set up the server names and so forth, which is why that host name is important. Because I recommend you use that host name to set up a server name, that's add server name, and now you can do sp-add link server based on those names. And Docker Compose is pretty interesting because if you want to do those linked servers between two containers, it's got a little private subnet that it builds. Or the link server could be in some other environment that you got to go connect to. Yeah, today's just SQL Server link servers today. But hey, come talk to me afterwards. I'd like to hear that scenario more to see how can we support that. Any other questions? Yeah.
For this Docker, it's one of the Docker containers. Is there any way, like, because currently we use database clustering. So this is the one container. Is the possible we them as a one cluster?
You use a failover cluster today for SQL Server, you're saying?
Yeah.
Yeah. Yeah, so the answer to that question, the question is how do we do clustering and high availability and those kind of things? And containers can support that, but what we recommend is Kubernetes. So if you've got a failover clustering environment today with Windows SQL servers and you'd like to move to a production version of containers with SQL, you should start using Kubernetes. Kubernetes comes in with built-in failover clustering in a shared storage environment. There's nothing, SQL doesn't have to do anything. We just declare ourselves as a stateful set and we're up and running in a failover cluster environment. What's needed after that, though, is availability group technology, which right now we partner with a third-party company, DH2I, and they have a solution that integrates with our availability groups to make it a complete HA system. So it's pretty cool. Other questions about containers in general in SQL? Does this concept make sense? Do you understand what we're doing? Yeah, go ahead. In production. So the question is that you talked about development environment, which is a great use case for it, right? But what if I want to go use Enterprise Edition now in production? And you can, and we have customers doing it. And what they do is they actually use multiple containers in a virtual machine as production SQL servers, as a consolidation strategy. So yes, it's a SQL server on Linux. So as long as all the features we have in Linux help you support your environment, containers are perfectly capable of doing that. Yeah, one of them is the patching scenario I just showed you. So if you want to have a more online way of patching SQL Server, containers have a much better solution because you're stopping the container, right? Starting a new one with a new update, pointing at a database, and so all of a sudden I could patch a SQL in 30 seconds. So I can be online, I can be almost online doing a patch of a SQL Server. That's one huge advantage. Another advantage is consolidation. Like I said, you have an environment with virtual machines, and you're like, hey, I'd like to consolidate my VMs somehow. Containers would be the way to actually do that. And then the third option would be running in Kubernetes. Like if you're going to run, if you like Kubernetes as a platform, you run on SQL Server, you would need container technology to do that. Yes? Mm-hmm. Yeah, the question is like what about all this stuff I put in scripts and so forth that are in my current SQL Server? Well, here's your trick. Your system databases are on persistent storage. So when you do an update to a SQL Server, we don't touch that. So you're literally going to be switching to a new container, pointing to also your system databases, and all your stuff's there. You don't have to write any extra scripts. It's already in your system databases. So you wouldn't be running extra scripts at all. And one of the cool things about this is, I didn't mention, you can roll back. Cumulative updates in SQL Server major versions are compatible with each other. So you could go to CU6 in production. Oh, there's a problem. stop CU6, start up CU5, you're back and running because they're compatible between each other. That's pretty cool. So that's another reason and a benefit of running containers. Okay, sorry, go ahead. The question is, how big does a VM need to be? It needs to be as big as your core and memory needs for your SQL servers. So think of it this way. If you're going to run SQL Server in multiple instances in a VM today, it's the same thing. It's the same concept. So, and remember, these don't talk to each other. They don't share resources. Like one SQL Server could hog up everything. But we have configuration options for you to control that. Hey, I can affinitize this SQL to use these cores and only use this memory. And this one uses these cores and this memory. So you can actually manage all that yourself. But you have to decide how big is that overall VM going to be. What I found, to be honest with you, about this consolidation play is many customers over-provision their VMs for SQL because they don't know. But then I've had customers saying, well, I gotta consolidate this down. I gotta save costs. I'm like, okay, you gotta do an exercise to figure out how much cores and memory you actually need from these things. You do that, and you can actually go through this strategy. Okay, let's switch on and talk a little bit about the DevOps environments. I promised you we're gonna talk DevOps with containers. Let's move on and talk about that. Okay, so you might not have heard of this before, but there's a very interesting thing that we have called a data tier application framework. It's an API to build something called database projects. And what it deals with is schema. What I meant by my schema, by the way, because there's a term called a schema as a group of objects in SQL. But I mean schema more of like all your objects together, your tables, your indexes, your columns, your functions, your procedures, all the database objects, I'm going to call a schema in this context. And for years, we've had something called SQL package. It's a command line interface that uses that framework. And you can use this SQL package framework to extract out your schema into something called a DAC package or a DAC pack. So a DAC pack's a binary file that is encoded to have all your schema. Well, why do you care about that? Well, you can take this DAC pack and go to a different database and publish it. You can say, hey, I'd like to go take the schema out of one database and publish it on a different one. And we've allowed you to do it with SQL package. In addition, I can create something called a backpack, which is exporting my schema and data from a database and creating a new one or putting it into an existing database. So what we've done now as a developer, and we've had this for a long time, as a developer, we build something new, something called an SDK-style SQL build project. And we've incorporated this as an extension in Visual Studio Code and Azure Data Studio. So now we can use the .NET type commands, that's SDK-style commands, with this new package called build.sql. You can use a .NET new. They build something called a SQL project. A SQL project, which we've had for a while now, but with this SDK style is much more efficient. And it's basically a YAML file that has descriptions about how to go build a DAC pack and publish it. So with this new technology, you can know a .NET build, and you can take a series of SQL scripts, and you can go build a DAC pack. So what do I mean by some of these terms? Like, why is there an advantage between the old way and the new way? Well, number one, I can take a series of SQL scripts from my database objects, and I can put them in a single directory, and we do something called globbing. We'll just find all your SQL scripts in a directory, and we'll say, oh, those are all your objects to go create. And we know how to order them. So if you've got tables, indexes, procedures, we'll order them in the right order to install and deploy everything so there's no dependency problems. And then we have this concept called pre and post deploy. We'll talk in a second about some examples for that. So SDK style projects through Visual Studio Code and Azure Data Studio provide a convenient way, and behind the scenes, the graphical interfaces will run those command line commands to build a DAC pack for you of your schema, but do it based on scripts that you've built as a developer in a very efficient way. So once you have this project and this DAC pack, what do I do with this thing? Remember, I said you could actually put this into another database? We have a publish experience. So I can take, and it uses the framework here to take a DAC pack package and go create a new database or an existing database, run all that stuff I said. And you're like, Bob, wait a minute though, I'm missing, where's containers come into this thing? Well, this is where it gets fun. I actually can use this experience to start up a new container automatically and then go publish that in there. So it's an integrated experience to do what I first showed you, how to start up a container and how to build a set of scripts. Instead of customizing an image, you can use this process through Visual Studio Code to go publish the scripts required for your application, all in a very integrated experience. And this is what's interesting. Because Azure SQL Database today, besides the trial version, costs you money for an Azure subscription, we have something called the Azure SQL Database Emulator. The emulator allows you to develop for free and then do this publish process to an Azure SQL database. So develop on a container, even on ARM, even on ARM, develop on a container for free, and when you're ready, publish it to the cloud, to your actual production database. And then we're going to talk about in a second how we can use GitHub to even make that more powerful. So we call the Azure SQL Database Emulator. What we mean is we're using SQL containers to emulate SQL in the cloud for you as a developer. So develop locally, move to the cloud. So in this database project, I want to break this down for you and show this to you before I show a demonstration of this. So number one, when you have these scripts, you might do something called a pre-deployment script. That's up to you, and you can declare it for us. And one thing you might do is do some configuration. You mentioned about configuration things as a developer. You might use this script to do instance-level configurations, max server memory, other types of things that are a configuration of your SQL server. So we'll run that first. Then we will glob all your SQL scripts that are built based on your database, indexes, tables, procedures, etc. Globbing means you don't tell us the scripts. We'll just go find all of them in your directory and run them. And you have a way to exclude certain ones if you don't want those to be in there. And then finally, the post-deployment script is interesting. I use it for that, populate data and testing. So once this is done, this post-deployment will run in my examples, and it runs in this order. We'll run the instant config. Notice how we order the actual globbing of the objects correctly so dependency failures don't happen. And then we run post-deployment. So you may be asking yourself, like, why would I want to do this one here? Like, why would I want to do a test? So I want to show you an example of a scenario that you might make a mistake as a developer where you can use this process to make sure that you can do local testing to avoid a performance problem and use this method to do it. So when I do that process and I fix my problem, which I'm going to show you in a demonstration, I want to make a change. But in a change, I want to do it incrementally. And this is where it all comes into play. If you make a change to an object, like let's say a stored procedure, you're going to fix a stored procedure problem in all those things I just showed you. Notice here, you do a build to make sure those syntax problems. A publish only sends incremental changes. That's powerful. You could have 50 scripts out there for 50 tables, and you change one file. We're only going to go send the one change when we do the publish process. So it's incremental building of your database objects. Then you can read post and deploy. Now keep track of pre and post deploy. The only problem with these is we don't check syntax checking on build. So it could be during publish, if you're not careful with these, you actually run into some failures. And then this is what I mean by testing. You ever heard the term smoke test? You guys use that before as a developer? So I'm going to suggest to you that you can use post deployment as a way to do a smoke test at the end of this process. So again, you do a build, you do a publish. Then part of your publishing, though, is going to be running your smoke test. So right out of the gate, you could run a test script to go see, did this have a problem? If it had a problem, you'd make a change, run it all over again, and then you're good to go. And then when I show you this, I'm going to show you how to integrate with GitHub. So let's go look at it. So I'm running Visual Studio Code. And just to let you know, if you go back, look over here in the GitHub repo, I'm running this one, database projects. So in here, what I'm going to do is I've got a directory, database projects, BW SQL. And what I'm going to do is I'm going to first create my project. It's going to create a new directory. And then I'm going to copy my SQL scripts that I need from here into that directory to build the project. So if you go look at GitHub here, yeah, so let's go and do that. Let's go in here. We're going to create a new project. Now I want you to pay attention to the choices I'm making. I'm not going to use the emulator. I'm going to use a local SQL Server Development. And I'm going to give it a project name, BWDB. And I'm going to pick where do I want these files to go for my project. So that location I'm going to pick is where I have these scripts. So I'm going to pick here. And then this is beautiful. Because we're going to use containers, I can pick my version. So I'm saying, oh, hey, why don't you go pick SQL 2022? and I'm going to pick the STK style project type. I'm going to kick it off, and I'm now going to have a project. But I don't have any files, Bob. Where are the globbing happening? No problem. I'm going to go over here, and for the files, let me make sure I'm picking the right one for my instructions. What do I want? I want the customer SQL script, that's my table. I want the index to build the index, and I want the get customer by ID, that's my stored procedure. And I'm going to create a post-deployment script to populate the data itself to do the smoke test. So let's go do that. Let's go over here. Let's get create index, customers, and that's the 3 objects I need. Put them in here. Now, when I go over here, this is what I love about this. Because we're supporting this globbing concept, I hit refresh. There's my scripts, right? But what I want to do is add a post-deployment script. So I click here, and I'm going to say, hey, populate data. And I'm going to go back over here to my populate data script. Just open it up with Notepad, and I want you to see what it does. Oh, didn't do anything. Ha. Here, this is what I'm here. That's the one that's getting built, sorry. That kind of scared me. It was empty. So all it's going to do is going to populate some data. So let's do that. So let's go run this. We'll save it. Now I've got my populate data. So what am I first going to do? I'm going to do a build. So I'm going to go build. And in the command line window, you're going to see the steps of what's happening. What it's doing is running that .NET build that I showed you command line-wise. It's running that behind the scenes to build your project. And what you now have in your, once you've done this build, is you have a SQL project file. This defines in YAML what we're going to do. If I scroll down and look at this, notice here that it has the post-deploy script for me. So it's going to take, but it doesn't list all the SQL scripts for the tables, objects, and procedures. That just comes by default. But it specifically says, hey, go run that as a post-deploy step. So if I go back over here now, let's go publish it. Now this is where I get to go choose that I want to publish this to a brand new container. Remember, Docker shows me the containers I'm already running. See, I've got these here running. In fact, what I'm going to do is I'm going to go ahead and just delete this one. I don't want this one right now. But I do have, and it had 1402 as the port. So when I actually go delete this new container, actually I think this thing is over here still cooking. Yeah, let me shut this thing down. By the way, for Docker Compose, you can say Docker Compose down, and it blows away the whole thing. So if you want to remove what I just did, I can do that. So this container is the only one running with port 1401. Why is that important? So when we do a publish, let's see what choices we get here. So let's say publish. The first choice is to a new SQL Server container. And the port number is key here. I want it to be port 1402 in this case. Let's pick 3, just to avoid any conflict with what I might have had. Here's my password that I need. SQL. Remember we talked about an SA password needed. Confirm it. Then I want to run SQL Server. And I accept the EULA agreement. And then, look at this, I get to pick all those different versions, because I picked 2022. Remember I said there was updates for these different versions? Look at that. Those are all the choices I have. So I can say I want latest, but I don't have to do that. I don't have to use a profile, and I want a new database. Here's the key. So when I'm finished with this, I expect this thing to go through, create a new database, first of all, start up a container, create a new database, and put all those scripts in there, put all those objects in there for me, and populate my data. So I run it, and here we go. Now, one thing I've seen sometimes in this is that it has its own retry logic. So if SQL Server is starting up and it says waiting for 10 seconds, so it's going through the process almost like those scripts I showed you earlier, where it's starting a container, the SQL Server container, and then trying to go run those scripts, but it has retry in case it went too fast. Notice it says deploy DAC pack in progress. So we're taking the DAC pack that we built, and we're publishing what's inside it, which is our objects, and all our scripts, and putting that inside the SQL Server running container. And at the end, running the post-deploy process, which is what? Populating my data. Says it's finished. This is great. So I need to do this smoke test, but I didn't put it in as an automated way of doing it. So I want to show you, so okay, it says it published this successfully. So let's go add a connection. Let's say localhost 1403. And database name is BWDB. And SQL login, say, and SQL 2022 is fast. Yep. No. Trust certificate, boom. Look over here. This is like looking at Management Studio. I'm looking at what's over here, and if I go down to tables and objects, do you see I've got the object I need? I even have my stored procedures. Now, I haven't done my smoke test yet. So what I'm going to do is I'm going to go run this stored procedure and see what the plan looks like for the procedure. I populated data, a query plan. Because the way I built my design as a developer, I know it should use an index because I set this all up correctly. I'm a smart person. So let's just see if it actually works that way. So I'm going to come over here, and I'm going to run this exec proc with plan. So here's an example of running that stored procedure with a test value, but setting up a command to go look at the plan after the fact. So let's run it. And I'm going to pick that local container to run it on, and it's going to finish. Now, if you look over here, I want to show you this. This is what this output looks like. Notice here, from this plan, it's doing something called a table scan. Do you see that? That is not my intention. Like it should say index seek or something like that. So with my manual smoke test, I know it's wrong. Like, crud, what's going on here? So again, I'm just on my laptop, just developing before I go into production. I'm like, this is bad. So I'm like, what do I do? Why is this not working? So let me go do this. I did a little research on the internet. Maybe I used generative AI, I don't know. And I said, hey, why would I hit this problem? Well, one of them is called an anti-pattern query. This is the stored procedure definition. If you go look at it, let me go back and pull that up. So inside here, this is inside our project. This is the stored procedure definition. And it uses a parameter for an integer to look up a customer. But if you go look at the table over here, if you look at the columns, you can see that the customer ID is not an integer. That is a typical anti-pattern query problem. SQL can convert that correctly, but it can't use an index if those are different data types. It's a data type mismatch problem. Well, crud. What do I do? No problem. Go in here, change this to what? nvarchar 10. Save it. Great. Now what do I do? Let's go back to the database project. Now let me go look at this to make sure. Yep, nvarchar 10. So remember I told you what I'm going to do? I'm going to do a build. And then I'm going to do a publish. And we'll only publish the incremental changes to the stored procedure. So let's publish it. Aha! I already have an existing SQL Server because the container's running. Pick existing, don't use profile, pick that one, that's the container, that's the database, publish, go. So now it's it's changing the stored procedure to fix the code to make sure it's using index. So it's going that same process, deploying the DAC pack, but only incrementally applying the procedure change that I need. Now the only problem with this process that I have so far is I could have been smarter because it's still trying to go populate my data. It truncates and repopulates the data. I could have gotten smarter about that probably. But how do I know it's working? Let's open a file. Let's go back over here. Get customer, here, exec proc with plan. Run it again. Run it against that database. Now go down and look at the messages below and see over here. Whoops, I can get this properly over. Aha. Man, this is just these windows are too wonky for me. You see it says index seek? So it's using an index now. So I fixed the problem. Great. Well, that's awesome, but I did it all kind of manually, right? I did a little test manually. And in fact, the problem I run into now with my company is they told me, hey, we got to be part of the GitHub world. We need to be in a DevOps environment. So this is really beautiful what you just did. But what I want you to do is go publish your application and project in the cloud, in GitHub, and I want you to automate what you just did. Can I do something like that? You can. Let's go show you what that looks like. So I did all this locally with a container, but wouldn't it be cool if GitHub could run my container for me automatically and do everything I just showed you? It's possible with GitHub Actions. If you've not seen this before, it's incredibly powerful. GitHub Actions support a CI/CD process with DevOps. How? Well, it supports a concept called a workflow. You can set up a series of events or jobs to go run things for you based on changes of code you make. And here's the thing that's really amazing. It has something called a runner. And there are certain classes of runners that are fairly smaller that are free. So free running of containers if you want that to be the process to go check your code out. I can start SQL Server dev editions of free containers with a free GitHub runner, all part, and I can run effectively that same process I just showed you with database projects. But instead of just doing it on my laptop, I can set up a repo and have GitHub do all what I just showed for you. So now the GitHub SQL action comes along to be part of that. And that includes things I just showed you, an SDK-style project. You can publish a project, and you run scripts in an automated fashion, all using this GitHub action concept. So let me show you what it looks like. Keep in mind everything I just showed you, how to publish and build and do testing. So in the cloud, first of all, over here in Visual Studio, I have a GitHub repo with all my stuff, my project file, everything that I showed you before I have, and I put that in a repo. All published, all committed up in my repo itself. But I added something called a test folder and something called make sure no warnings. SQL Server is so powerful, man. Inside the engine is a way for you to run a query and go automatically query and see did it do an index seek or a scan. So I built this query to go run what's called a DMV query inside the plan in cache and say, hey, do you see a warning? In fact, let me scroll that out a little bit. Do you see a warning over here? Looking for warnings. Do you see that in the XML of this? And here's what I do. I say, oh, if there's a row that comes back and says there's a warning, I insert it into a temporary table. I select from it, and there's a syntax for the SQL command utility that if you use the exit command with a query, it returns the number back. So for me, a 0 is success because there's no warning. Anything greater than a 0 is a failure. Because a warning shows up in what context? If I don't use an index because of a type conversion problem. So the engine knew, actually, by the way, that I had that problem. It already knew that I had this type conversion issue and couldn't use an index. And I have a way of querying and finding out, did that happen? So you're like, well, what do you do now? Well, I can use a GitHub action to run this automatically anytime I make a change to my code. Let's show you what it looks like. So I've got my own repro for this app. And again, all it's available for you to take a look at yourself. I built this app repo with all this code, and here's something called workflows. And in workflows, there's a syntax for something called a GitHub workflow YAML file. In here, there's syntaxes for do things that are specific to GitHub, like doing things like support running a container. Notice I've got that same syntax for using a SQL container. And then the SQL GitHub action has specific things like, oh, hey, go build my project for me and go publish it. But notice this one here. This is the key. It's going to do everything I showed you to create the database, publish all the objects, populate the data, and at the very end, it runs that automatically. It runs that make sure no warning script with SQL command. So in these GitHub action steps, if the result back is a 0, it's successful in this case. If it's greater than 0, it's a failure. So I'm automating everything I just showed you by running that script at the very end, and if it's 0, everything worked. If not, and here's the beauty of it, of GitHub Actions, it won't commit your changes. So if this fails and I submitted like a new PR for a change to like a SQL query, a table, a procedure, it would fail the PR and it wouldn't put it in the repo itself. So now you've automated DevOps. You've actually caught this stuff before it goes in production. So if you go look at the GitHub workflow, one of these examples, right up here, let's go back to the actual repo. Notice it says at the top here, actions. These are called GitHub Actions, and I've already published my initial repo. When I made that first commit up there, it failed. Well, it failed because it ran the step here to go see that there are warnings. Notice this test for warnings failure. Well, what do I do now? Well, watch this. So here is that repo. Here is the procedure. And what did we say it needed to be? Does anybody remember? in varchar10, right? Save it, go to GitHub desktop. There is that change. Fix anti-pattern. I can't even type. Anti-pattern query. Commit it. Obviously, I could have used a branch here. I'm just using my own little private thing. Now, here's the beauty. I've set up that GitHub action that when I push that change, it kicks in the workflow. So let's go back up here. Let's go back up a level. Back up a level. Ah, you see it running there? It automatically kicks off the workflow again. And what it's trying to do is it's trying to publish any incremental changes because I'm only publishing incremental changes, and it runs my smoke test. And if it works, please does it work? It'll come back with no warnings because I fixed the index problem. So do you see the beauty of this? I now get to automate smoke testing for SQL stuff inside GitHub, and this could have been part of a larger repo of my entire application. You can chain these workflows together. You could have an app workflow change, you have multiple app workflow changes, and then a SQL one is part of it. So let's see, is it gonna work? Let's go click on it. We've got 3 minutes left in the session. Build and deploy. Oh, it's almost there. I'm gonna let it go and see if you have any questions right now. And we have a resources slide to bring up in a second. Any questions about what I showed you as this thing is hopefully working? Yeah.
Normally, whenever we have some web application very associated with our data.
Yeah.
So every time whenever we deliver the new feature, we use this.
Right.
So what's your suggestion that we should put this kind of Git action at the same Git repository as our?
Yeah, Mike, the question is like, hey, this is pretty cool. How do I do this? You can do, the question, should I put in the same GitHub repo? That's all up to you. My understanding, you could even change these workflows across repos. But yes, so you could even have a repo with an app, a repo with a database, chain the workflows together and make sure that things work and are coordinated. Or you could have a repo with both of them in there. I've seen both techniques used. The key is this. Just like you've been able to do things before with applications with GitHub workflows to test your app, you can now test databases. And because of our GitHub SQL action, it's a lot faster. And we're using GitHub to spin up a container to do it for us. That's pretty cool. And that container image, by the way, I can specify what version of SQL that container image is. So if our developers say we need SQL 19 CU6, that could have been part of my declaration. Looks like it finished. Looks like it worked. Yay, you see it's green? We're all happy. But I thought you might find it interesting. This is a basic, there could be other smoke tests that you have. Other things you might do from a database perspective. Making sure I don't have an anti-pattern query could be one of those.
You have smoke test examples?
This is one I've built. I don't have others. I've just started this process myself, actually. So, yeah, I mean, there's other smoke tests I think I want to go build as examples and put in a GitHub example and show other workflow examples for you to do in your environment. But yeah, this is kind of my first attempt. For me, I'm a SQL guy for like 30 years. And I'm like, oh, I want to make sure an index is used. That's the first thing I want to see. And SQL has a way to query the engine itself to make sure it happened. Pretty cool. Okay, so just one last slide here. Been a great audience. I appreciate it. A couple things to keep in mind here. So if you look at this, so this is the thing that's interesting. You can actually publish directly into SQL. Let's say you're pretty comfortable with this whole container process. You could actually set up another workflow that if that passes, go publish it into my cloud database. So that's a great example, I would think, of using this in terms of DevOps and then eventually pushing it into a production system. It could be an existing SQL somewhere in your environment, or it could be in the cloud. And then this one, be careful. If you don't know what this is, if you're publishing DDL changes, table changes, index changes, things like that into production, you could block your application. So be careful when you actually go through those processes of actually making table definition changes, column changes. Stored procedures are not typically a problem, but those table changes, index changes, things like that, that could actually get you into trouble. I'm going to leave this up here right now. Here's some resources for you. Those are the scripts, again, up there at the top. One thing, I do write books, and I'm not trying to shamelessly sell books. I take all my royalties and give them to charity. I don't even make money on these things. I don't care. But I've written about 4 of them now, and one I don't list is I wrote a book on Linux, my very first one. So there's a book out there for A-Press called SQL Server Linux. Take a look at that one as well. It has containers inside it. The SQL 19 book also has a lot more information about containers. 2022, I didn't do that because I already published things about it. But yeah, Here's some information about GitHub SQL actions, about database projects, more about SQL containers, and then the scripts and demos and my deck are all, and I'll get those decks, because I'll put our keynote deck up there as well. I'll get that done later today. We're just about out of time. Great audience, thank you. Did you guys enjoy this? It was good? Thank you so much. Enjoy the rest of the conference. Appreciate it.